Welcome to R-Tools MAXX, Mersen's free online simulation software that allows you to select a heatsink solution tailored to your application. Sign in to begin finding the heatsink you need. Create your account by putting in the email and password you would like to use with your new R-Tools account. Click Agree and sign up, and an email will be sent to your inbox shortly with the link and steps to validate your account. Once you're signed in, you will see the project screen, which will show all your R-Tools projects. You can see the status of your project, its details, and edit, copy, or delete them as needed. To start a new project, click the orange New Project button to begin. You can return to your project menu anytime by clicking the Projects button. You start by putting in your project name. You can enter any notes in the description, and then you select between an extrusion or MBF, aka mechanically bonded fin. We will walk through the design process for an MBF. Then, you select your preferred units and create your project. The first step is to put in your boundary conditions. Input the ambient temperature surrounding your heatsink. This temperature will be used at the inlet where the airflow enters the system. For altitude, please input the meters or feet that your heatsink will sit above sea level. Here, you can define the maximum heatsink volume available for your project. You may specify the width, length, and thickness of your base plate. The maximum height limitation you put should account for the base plate thickness. This input will also influence the recommendations from the fin estimator. Here, you define the maximum heatsink temperature allowed for your project. This allows the fin estimator tool to recommend heatsink designs to meet this performance. If your boundary conditions lie outside of the minimum and maximum inputs allowed by R-Tools, please contact the engineering team for your region through the Help button to look into custom solutions for your project. All inputs are saved automatically. Even if you close your tab, you can come back to see all your parameters as you set them. Moving on to the Source Layout tab. You may place 2D representations of your heat sources on the maximum baseplate dimensions that you input on the boundary conditions page. You add a heat source by clicking the plus icon. Hovering and selecting the pencil icon in the top right corner of the heat source, you can then name the heat source as well as define the power, size, and placement. You may also drag your heat source to the location you need. Using the top toolbar, rotate the heat source, copy the heat source, center the heat source on your heatsink, or delete the heat source. You can adjust your view of the layout with Zoom, or turn on Snap to Grid and adjust the size of the grid to assist in placing your heat sources on your heatsink. With Snap to Grid, the corner of your heat sources will automatically align to the closest grid. If your placed heat sources overlap, your estimated and simulated performance will be incorrect. Please ensure your heat sources are placed properly. Moving on to the Flow Conditions page, you will define your airflow type for your heatsink, whether it will be cooled by natural convection or forced convection. For natural convection, specify the orientation your heatsink will be sitting. You can see the projected airflow direction on the base plate here. For forced convection, specify the maximum allowable pressure drop for your project. You can define your flow type from a list of generic fan sizes, flow rate, or velocity. For push and impinge cases, we assume that the heatsink is perfectly ducted, meaning that all the airflow is directed to go through the fins with no air bypass outside of the fin area. For impinge, you can further specify the approximate fan coverage over the effective length of your heatsink. If this assumption does not fit your project conditions, then please contact an engineer through the Help button to develop a more custom solution. To the next tab, the fin estimator will take a few seconds to load, then offers a suggested and low pressure fin option. The suggested fin is the most cost-effective fin within 10 millimeters of your maximum height requirement that meets both your thermal performance and pressure drop. The low pressure fin is the fin that gives the lowest pressure drop within 10 millimeters of your maximum height requirement that still meets your temperature requirement. The fin estimator message will give recommendations based on how well the suggested fin meets your project requirements. You can choose your own custom fin and compare its estimated performance to the suggested fin to select the design that best suits your project needs. The fin estimator can only give a rough prediction of how this fin selection would meet your thermal performance. Once you have selected your fin, continue on to Solution to run a simulation to receive accurate results. Moving to Solution, the Summary tab gives an overview of your project parameters. Click Run Simulation to begin running the solution. Even if you close out of the tab, the simulation will continue to run. Once the simulation is complete, the solution message will give recommendations based on how well the design meets your thermal requirements. If the simulation results are acceptable and within your project max parameters, you can export a PDF report of R-Tools MAXX results as well as download a QFin file. You may go back to any previous tab to make adjustments to your design. However, any changes to your inputs will delete the current simulation result. If you would like to preserve the simulation result, you can go back to the Project menu and copy the project. You can then make your changes on the copied file. These files can be sent to our engineering team with the Quote tab to receive a quote on your design. Thank you for using R-Tools MAXX.